So hello everyone, this is lecture 25 for the mathematical physics, in which we were studying about the differential equations. In the last lecture I told you about the linear ordinary differential equation, how to solve that. We get some formulas, and the formula was like y into integration factor equal to rx if whole integration plus c. So that was the formula. So I have given you this question to you to solve. So if you didn't make it, then just see the solution. This is the equation y dash plus 2y equal to this whole ex 3 sin 2x plus 2 cos 2x. So this whole function is rx, and this is py. So integration factor will be e to the power p dx. So 2x. It will give us if equal to e to x. Now we use the formula y if then rx dx plus c. Okay, so now you need to remember this formulas, otherwise it will be consuming very much time in the exam. So if you get this type of form e to the power ax sin bx, and then its integration will be ax divided by a square plus b square, a sin bx minus b cos bx. So remember this formula. For this ax cos bx, you will have this term will remain same, and inside you will have cos bx plus b sin bx, a cos bx plus b sin bx. Okay, so how can you remember this? Just remember this term, and inside if it is sine, then it will start with sine then cos. If it is cos, then it will be cos and then sine, and for cos it will be plus, and for sine it will be minus. So remember these formulas, these are very important formulas. It will save a lot of time for you in the exam. So now when you just substitute these values, just divide this in two integrations. For ax sin bx, here a is 3, b is 2. Use the formula direct and solve this. You will get this solution. This will be your solution. Okay, so here just you have to put these values and you will get the solution. Now let's see one more example. X dy over dx plus 2y equal to cos pi x divided by x, and condition is given, initial condition, that is y at x equal to 1 equal to 1. So divide with x to the whole equation to make it in the linear form. So it will be dy by dx plus 2yxy and this. So this will be our rx, this will be our p. So you can find the if e to the p dx. It will give you x square. Now just substitute in the formula y if, then r if dx plus c. Okay, and this will cancel out, and cos pi x will give to you sin pi x divided by pi, and now you can use the initial condition. You will get c equal to 1, and you need to find y at 2. So you can find y at 2 will be 1 by 4. So that's how you can solve it. Now let's see one more example. Dy by dx plus tan x y equal to cos x. Here condition is given y0 is 0, and we need to find y pi by 3. So this is rp, and this is r, this is p, this is r. So integration factor will be e to the power tan x dx, and tan x dx is nothing but sec x, so log sec x. So e to the power log sec x will be sec x. That's how you can find the if. So if will be sec x. Now use the formula y if, then this r into if and dx plus c. This will give you 1, and this will be your solution. Means find the value of c, then find the value of pi by 3. Your answer will be pi by 6. Now let's see one more example. X dy by dx minus xy equal to e to the power x. So divide with x whole equation, then you will get minus 1 as your p, and e to the power x divided by x as your rx. So if will be e to the power minus x, and substituting in the formula, this will give you 1 upon x, so log x. Now you can use this condition to find c will be e, and after substituting with c in this equation, you get the yx. Okay, and this will be your yx, y equal to e to the x log x plus e to the x plus 1. So here in this lecture I am not explaining each and every step to you, because you are a student for the PhD or the MSc. So I don't think there is need to explain each and every plus minus. Okay, so make it work. Now this was the linear form equations. Now we can get sometimes the equations which can be reducible to the linear form. So how can you do that? So there are some equations which can be reducible. I will give you the example so you can solve them. So this kind of equation where you will get dy by dx plus py equal to qyn. So this type of form can be reducible to the linear form where p and q are the functions of x or constant. Okay, so how can you do that to convert this into linear form? Just divide this whole equation by this yn, means make q here. So divide by yn, you will get this form, p 1 upon yn minus 1 equal to q. Now we will assume this term as z. Okay, because we need to get some this kind of form, means this will be z dz by dx plus pz equal to something q. So that's to find that equation we will substitute this as z. Now this is equal to z, and if we reciprocal this, you will get this. Now differentiating 1 minus n will give you this dy by dx equal to dz by dx. Now see, this is y dash and this is 1 upon yn. So you can see 1 upon yn dy by dx is here, and this is nothing but equal to 1 upon 1 minus n dz by dx, this. So now you can use this whole equation to equate this. Now substitute in place of this, you will get this plus p, this whole term is z, so you will get this. Now multiply with 1 minus n, so you will get dz by dx plus 1 by p 1 minus n z equal to q 1 minus n. Now see, we have the linear form. Now this is the whole function of x, and here it is z, and here it is all the function of x only. So this will be our rx, this will be our p, and this will be our y. In place of z, means in place of y we have z here. So we can solve the equation. How? Z if equal to z into r dx plus c. Okay, and in the last, when you get the equation, just substitute in place of z y upon y n minus 1. Okay, so that's how you can solve the equation, or you can convert this type of equation into a linear form. Let's see some examples how can we convert, then it will be better understanding them. So given example is this: y dash plus 1 upon 3y equal to 1 upon 3 1 minus 2x y4. Now see, to make it only function of x, we need to remove this y4. So divide with y4 to the whole equation. So here we'll get 1 upon 3 y cube, here we'll get 1 upon y4 y dash, and now this we get something like this. Okay, now as in the steps we know, put the 1 upon y3 as z, so y minus 3 equal to z. Here we will get, after differentiating, minus 3 y minus 4 y dash equal to z dash. Now from here y dash y minus 4 will be minus 1 upon 3 z dash, and see, this is nothing but this. So in place of this we can write this whole term. So minus 1 upon 3 z dash plus 1 upon y3 z, so z by 3 equal to 1 upon 3 1 minus 2x. Now multiply with minus 3 to the whole equation, you will get z dash minus z 2x minus 1. Now see, this is a linear form. You have p minus 1, you have r 2x minus 1, and this is this. So you can use the formula z into if equal to integration r if plus c. Then in the last you will get the solution y minus z. So in the last you will get this y minus 3 equal to this, means you will get z equal to this, and z is equal to y minus 3. That's why we write this equation as this. So here let me give you a trick to solve the integration fast, where you are having having the products of x. Okay, so means functions of x, if u and v are functions of x and they having a product and dx, you need to integrate this. So you normally do the integration by parts. So to make it more easy, let me tell you what you will do. Just you will follow this series. Write first function as it is, then integrate second one v1, then minus differentiate first one, then integrate this v1 and integrate to v2. It will integrate to v2. Now again, then it was minus, now take plus and differentiate this and integrate this, then take minus and differentiate this, integrate this. That's how you will go on. Okay, and you don't need to again and again put the integration, and you won't be confused with this formula. Okay, and at some place you will get 0, so there your this series will end. Okay, so just follow the series. First write it as it is, then integrate second function, minus differentiate this, integrate this, now plus differentiate this, integrate this, then minus differentiate this, integrate this. v3 will give you v4, v2 give you v3. That's how you will go. Okay, so this will be very easy and very time saving for you. Now let's take one more example for to reduce an equation to reduce linear form. Now let's see, we have this kind of form: x dy by dx plus y x3 y6. So what we will do first, we will divide with x to the whole equation. So we will get dy by dx plus y by x and x square y6. Then we will do the same as we did in the last question. We divide the whole equation by y6. So here you will get x square, and here it will be 1 upon y5, and here it will be 1 upon y6 dy by dx. Now we do the second step, that is put 1 upon y5 as z. Then after you will differentiate this, you will get this form, and from here you get that this whole is equal to minus 1 upon 5 z dash. So you will get this form: 1 upon y5 is z. So now multiply with minus 5 to whole equation, you will get this. So this is a linear form, definitely. This is our p, this is our r, and z dash. So you can find the integration factor and use the formula and find the solution. In the last you will get this is the solution: 1 upon y5 x5 equal to 5 upon 2 x square plus c, and c will be minus 3 upon 2 using this condition. Now let's take one more example, a little bit tricky. So it is 2x y dash plus x minus 1 y square x square e to the power x. Now see, sometimes we have to take things by just looking at the equation. Now if you put y square as z, then you will see you will get 2y dash definitely as z dash, because y square will give you 2y, then again differentiating y with x you will get y dash. So after seeing this equation you can substitute the values, because here it is function of x only, so you don't have that factor which we were discussing. So put y square as z, 2y dash is z dash. So now in place of this you will get z dash and x. So x dz by dx and this. So divide whole equation by x and you will get the linear form. Now this is the linear form. This is our p, this is our r. So we can find the if. It will be this, and using the formula zif and equal to r if dx plus c. So this will be e to the 2x, integrating will be e to the 2x divided by 2. This you will get. Now using the no initial condition here, so this will be your solution. In place of z you will substitute y square, which will give you y square ex x e to the 2x divided by 2 plus c. This is your solution. Now let's see one more example of this type, where you have to see the equation. So dy by dx plus 1 upon x y log y plus this. So first you need to make this right hand side free from this y term. So divide whole equation by this y log y square. So you will get 1 upon x square here, and here you will get 1 upon log y, and here you will get 1 upon y log y square. Now see this equation and you can directly see, put 1 upon log y as z and you will get this. So how you will differentiate this? By the divide rule, square of the denominator, then differentiation of the numerator, multiply same as the same, put the denominator, minus differentiate denominator, multiply the numerator. Okay, you know this formula. So this is the formula. If it is u and v, then square of the this v square, put v as it is, u dash minus u v dash. So this is your formula I have used here. Then you will get this like this equation. So from here you can see this y dash dy by dx and 1 upon log y square. So this whole term is equal to minus z dash. So we'll put here this, and 1 upon log y is z, so z by x equal to 1 upon x square. Now multiply with minus 1 to whole equation, you will get this, and this is our linear form: minus 1 upon x as p, minus 1 upon x square as r, and you can find the if. You can solve the equation, you will get this solution. Okay, easy. Now let's see last example. So this is your question. X dy by dx y log y minus log x plus 1. Okay, given initial condition y1 equal to 3, find y3. So what we will do, we just divide this equation and form something like this. Means in the right hand side we will get this x term, and in the left hand side this and some y term. Okay, so what we did is here, let's distribute this y inside the equation. Y log y minus y log x plus 1. So this, we take the minus common here, and log x minus 1 y, so this will be like this. Now take this term in the left hand side, you will get this, and in the right hand side you will remain with this. Now what we will do, we will divide the whole equation by x, because here we have x coefficient, so we'll get something like this. Actually we divide this whole equation by xy here, so x will cancel out and y will remain, and here y will cancel out, x will remain, and here y will cancel out, x will remain. Now take this whole function of x to the right hand side and take this term to the left hand side, you will get this. Now we can see the equation and can observe that if we take the differentiation, put the log y as z, so we'll get 1 upon y y dash equal to z dash, so we'll put log y as z, so you will get the same as 1 upon y dash equal to z dash, so here it will be z dash minus log y is z divided by x, and this. Now you have the linear form, minus 1 upon x as your p, and this minus log x minus 1 divided by x is r. So use the formula, in the last substitute the value of z again, then you will get something like this. And here you use the formula I told you for the integration, for the product rule. Put this function log x minus 1 as your first function, and 1 upon x square as your second function. Okay, then solve, you will get this, and here solution will be like log x divided by x plus c, and after substituting the value y1 equal to 3, so at x equal to 1 y equal to 3, you will get c equal to log 3, and when you solve for the y3, then putting x equal to 3 in the equation, you will get y3 is equal to 81. So this will be your answer. So let's stop here. In the next lecture we will start with the second order differential equations. Okay, thank you everyone.